Alright, scholars, sorry I had to adjust the camera there. Today we're going to be talking about the greatest common factor of any two numbers. We talked about three numbers in class, but I'm going to stick with two, because I'm going to show you two different ways to do this real fast. The first way we looked at is that we could chart and we could do all the common factors of both of the numbers. And to do that, we make a nice little T-chart here. And we say that 60 can be made up of 1 times 60, or 2 times 30, 3 times 20. We can even do 5 times 12. Or 6 times 10. That's all the ways that we can get 60. This shows us all of our multiples. For 36, we can do it the same way. We start with 1 and 36, just because it makes 36. 2 and 18. 3 times 12. 4 times 9. Can't do 5, but 6 we can do. 6 times 6. 6 times 6 is 36. That means that 36 is a perfect square. It's just good to know. Looking at all the common multiples, we've got 1 in common, 2 in common, 3 in common, not 4, not 5, 6 is in common, not 10, not 9, 12 is in common. I'm going to circle that for some reason. I wonder why. Because 20, 30, 60, 36, and 18 are not in common as well. That means that the biggest number that both of these two numbers have in common for a factor is 12. So 12 would be the greatest common factor. For some numbers, this gets a little tedious, which is why I like the prime factorization method. For that, we just find the prime factorization of each number, and we multiply all the common factors together. For 60, I can go 6 and 10, just because it's divisible by 10. I'm going to make that real quick and easy. 6 becomes 2 and 3. I circle my 2 and my 3 because they're prime. And my 10 becomes 2 times 5. And I circle them because they're prime. I'm also going to list those factors out now. Just like I would if this was a prime factorization problem. I'm going to go 2 times 2 times 3 times 5. I do the same thing for the other problem. 36. I already know that 36 is a perfect square, so I'm going to go 6 times 6 and break it down real fast. Both of my 6's have 2 times 3 as their prime factors. So if I list the prime factorization of 36, I simply get 2 times 2 times 3 times 3. It's great practice for prime factorization, and it works great for the greatest common factor, because now I'm going to go number by number and see if I have anything in common. I look at this 2 and I see, you know what, they both have a 2 in common. I'm going to circle these 2's and say, you know what, I've used that 2, but it's in common. I'm going to list it down here. They have another 2 in common. There's a 2 over here and a 2 over here. And the key is we multiply them together. Looking for any other common multiples, I got 3 and 3. Common factor, excuse me. 3 and 3 are both there, so I can multiply by 3. And now I have 5 and 3 by themselves. They don't have anything in common. You can't do anything with them. They just go away. We're finding the greatest common factor now, not the prime factorization. So all we have to do is just simply go 2 times 2 is 4, carry down our times 3. 4 times 3 gives me 12. That means the greatest common factor is 12, like we found before. 12 is the biggest number that will evenly go into 6 and 36. And that's greatest common factor.